4 engineering releases this week. NVIDIA Molt, a compact PyTorch native agentic RL framework. AMD Instella MoE 16 billion A3B, 16 billion total parameters, 2.8 billion active per token. NVIDIA Transformer Engine, BF16 and FP8 fused kernel guidance. TimesFM 2.5, an end-to-end forecasting workflow. I'll explain the mechanics, constraints, and key benchmarks. First, Molt from NVIDIA NeMo, claimed RL code footprint, roughly 8.6 thousand lines. Molt composes Ray, VLLM, and NVIDIA Auto Model with FSDP2. It ships under Apache 2.0 with recipes and a pre-built container. Recipes assume 2 nodes of 8 H100 GPUs, split for training and rollout. Second, AMD Instella MoE 16 billion A3B, a decoder-only MoE trained on Instinct MI300X and MI325X GPUs. 16 billion total parameters, 2.8 billion active per token. Weights are research RAIL, training code is MIT. Third, NVIDIA Transformer Engine documents fused kernels and an FP8 path with delayed scaling and AMAX history. Finally, TimesFM 2.5 offers Colab templates for probabilistic forecasting, rolling origin backtesting, XREG covariates, anomaly detection, and throughput tuning. Key updates: Molt, 3 invariants, token identity, policy version semantics, forward consistency, plus a streaming pool and partial rollout that broadcasts actor shards over NCCL. Instella, gated multi-head latent attention and far skip collective to overlap communication and compute. AMD reports a 12.7% pre-training speedup and up to 39.2% reduction in time to first token for expert parallel serving. Transformer Engine, fused modules and an FP8 autocast API. Tutorial inspects AMAX history and delayed scaling. TimesFM 2.5 rolling origin backtesting, probabilistic quantiles for anomaly detection, and throughput tuning. How Molt works. Runtime, an agent pool of VLLM engines behind a request router and a single trainable policy actor. A streaming pool keeps prompt groups in flight so engines don't drain while the actor trains. Partial rollout pauses engines and broadcasts actor shards over NCCL to each engine. Retained requests resume rather than being discarded. 2 modes: Env, where Molt owns the LLM loop; Chat Agent, where the user owns it via OpenAI or Anthropic SDKs. Molt runs a loopback server that decodes token-exact accumulations. Instella internals. Decoder only, 27 layers, hidden size 2048, and 16 attention heads. Vocabulary, 128,896 tokens. Each MoE layer, 2 shared experts plus 6 routed experts, chosen from a pool of 64 experts. That yields 2.8 billion active parameters against 16 billion total. Pre-training covered about 7.1 trillion tokens. Long context expanded from 4,000 to 64,000 tokens, using YAR-N and a larger ROPE theta. Weights, research RAIL, training code, MIT. Transformer Engine explained. It exposes fused modules. TE linear, TE layer norm, TE layer norm linear, TE layer norm MLP, and TE transformer layer. Fused kernels reduce kernel launch overhead in memory traffic. FP8 uses delayed scaling, an AMAX history, and hybrid E4M3 or E5M2 formats. Use TE.FP8 autocast when hardware supports FP8. Fall back to BF16 or FP32 otherwise. Benchmarks compare forward, backward, and optimizer latency and peak GPU memory. They validate trained models with an autoregressive generation test. Industry context. Hardware remains a constraint. Molt's recipes assume 16 H100 GPUs across 2 nodes. Instella was trained on AMD Instinct MI300X and MI325X GPUs. Packaging diverges. Instella waits under research RAIL, Molt tooling under Apache 2. Reduced precision and communication compute overlap are mainstream optimizations. Developer impact. Molt's compact codebase, about 8.6 thousand lines, lowers cognitive load for RL research. Instella's training code is MIT and reusable, Weights are research RAIL for research use only. Transformer engine fused blocks can cut latency and memory but require FP8 stability testing and AMAX tuning on your hardware. TimesFM 2.5 Useful forecasting templates. Replicate benchmarks on your infra. Opportunities. Molt fits agentic RL experiments. Multi-turn tool use and code execution agents. Instella's 2.8 billion active parameters per token reduce inference compute for long context workloads. Transformer Engine FP8 can free memory and increase throughput on supported GPUs. TimesFM 2.5 Faster back-tested probabilistic forecasting and anomaly detection. Limitations. Molt's recipes assume 2 nodes of 8 H100 GPUs, limiting accessibility for smaller teams. Instella weights are research RAIL, restricting commercial production use. FP8 benefits need hardware support and AMAX tuning. Not all GPUs have FP8 tensor cores. TimesFM 2.5 examples run in Colab. Replicate backtests on your infra. Bottom line. Releases emphasize inspectable, hardware-aware systems tuned for throughput. Molt, smaller code surface for agentic RL. Instella, open MoE with 2.8 billion active parameters per token. Check research rail license. Transformer engine. FP8 fused kernels for PyTorch, test per GPU. TimesFM 2.5, practical forecasting templates. Benchmark and license check before adoption. Sources are in the description. They include the Molt summary, TimesFM 2.5 tutorial, Instella MoE release, and Transformer Engine FP8 tutorial. Follow the links for papers, repos, ROCm posts, and Colab notebooks.